Welcome everyone to Cherre's session on making sense of messy real estate data. Today we're going to discuss how real estate data is inherently noisy, making it difficult to extract as much value as possible. By standardizing and organizing data to emphasize the relationship between entities, we can discover the complex connection between multiple sources of information that helps customers go beyond their current workflows. So we're really going to delve into that, and to get into more detail, let me introduce our speakers, Ron Bekkerman, CTO of Cherre, and John Maiden, Senior Data Scientist at Cherre. Ron and John, if you'd like to go ahead and introduce yourselves and give everyone a quick overview of your background.
Yeah, do you guys hear me?
Yes.
Good. I'm Ron Bekkerman, CTO at Cherre. Have been with the company for a year and a half. Before that, I was the data science professor. My PhD is in machine learning from the University of Massachusetts, Amherst.
Hi, everybody. I'm John Maiden. I've been with Cherre a bit over a year now. Prior to Cherre, I was working with JPMorgan Chase on the consumer side, trying to look at customer behavior and derive signals that we could use to look at the behavior and understand how our customers work with the products.
Thanks, John. If you guys want to go ahead and get started and delve right into the content, that would be great.
Yeah, totally. I'll start. So we'll talk about how messy the real estate data is and how we at Cherre are coping with that. So I'll start saying that the real estate investment business is very tough because investment decisions need to be made under a lot of uncertainty, and not even the uncertainty about the future, all the investment businesses like that, but rather the uncertainty about the current state. We need to have a lot of different data sources to make the right decision. And we need to connect all those sources together, because if, for example, you have sales data and you have management cost data, but you cannot say that this data belongs to the same property, your data is pretty much useless. We at Cherre are connecting different data sources, real estate data sources, and some people would say that it's very easy. Yes, it would be easy if the data was standardized and clean, and unfortunately, it is not. The most important use case in connecting real estate data is connecting over an address. So like, you know that this is the property and this data belongs to that property. The problem is that there are so many different ways to write the same address. And we at Cherre solved that. We built a model and we connected all these different types of addresses to the same property. Another use case that is probably even more interesting is to connect real estate data over the name of a party that is involved in real estate transactions. And here the problem is even more difficult. And by recently, it wasn't like people didn't even think that it would be possible to connect so many different sources over the name. And that's what the work that we're doing at Cherre. We managed to take all these names and connect them to the same person, Aaron Ziegelman. He used to do lots of real estate transactions in New York in the 80s and 90s. And so some of those problems we managed to solve. Some of those problems are much more difficult. There are 25,000 different ways to write the name of JPMorgan Chase. It would be all the subsidiaries, it would be all the branches, it would be all the different types of misspellings, and we have to merge them together into one name of JPMorgan Chase, and we have done this at Cherre. I can't say that we solved all the problems though. So there are many very, very difficult cases that that are not easy to solve if you don't have enough information. For example, we did solve this issue, JPMC and Chase Mortgage. We resolved that as JPMorgan Chase. But what about this name, for example? It really looks like it's the name of a person whose first name is Chase and the last name is Morgan. So do we know for sure whether it's a person or actually JPMorgan Chase written in a very strange way? Here's another name. those names are very similar to each other, right? And the second one actually kind of looks more like a bank rather than a person. This is a simple example. Tishman Speyer LLC and Tishman Speyer Corp can be easily resolved into one entity. But what about these two names? 123 Main Street LLC and 123 Main Street Corp. Is this the same entity or not? So people would say that in many cases it might not be the same entity. It might be one LLC that acquired the building at 123 Main Street, and it was another LLC that just wanted to acquire the same building, but the name of 123 LLC was already taken, so they took a different name. What about these names? Like the name of 123 Main Street Co. is actually ambiguous because you just don't know whether it's corporation or a company. This is an easy case. So you have Meryl Streep or Streep Meryl, it's going to be exactly the same person, right? But what about this? If you have David King and you just change the order of words in this name, you end up with King David, and King David can be a hotel, it can be a restaurant, it can be many, many things. Here's an easy example again. So I came up with a very long and rare last name. So we definitely we can easily figure out that it's just the second name is the type of the first name. But what about if it's not John but Joanne? So it can be the case that those are two names of different people. It can be husband and wife, right? What about if instead of John we have Joanne? This is even more difficult. Like, you know, Joanne looks probably similar to Joan rather than John. It's very hard to say. There is another aspect of name standardization, which is a cultural aspect. I happen to be a Hebrew speaker, so I understand that the first entity, the left entity here, is an organization, and the right entity is a person's name. But I don't speak Spanish or Chinese or other languages. So how can we make sure that the names of entities in other languages are being taken care of? So all these are very difficult problems, and we cannot solve them unless we introduce some additional information, and we need to represent all this information together in the form of the knowledge graph. And John will be talking about Cherre's knowledge graph.
So to take all this data, so as I said, standardizing addresses and names is a complicated process, but it allows us to make data connections that we haven't seen before. So to be able to connect data sets that might not have been connectable, both in the real estate space, but also in the, taking other data sources, maybe demographic data, maybe court data, anything where we're thinking of that is relevant to what we want to do, but is not something that normally would have joined into the existing property data we would have. Now, looking at a commercial real estate knowledge graph, this is the traditional commercial real estate stock photo. They're staring off into the distance. They see the future and the potential. But from a data perspective, what's really going on here? If you know your data sources, you can say, well, there's a transaction for that building I can look at. I can see that the mortgage lender was listed for this building as 10th National Bank. I know how much the assessed taxes are on this property. Someone filed a permit, so I know contact information for a person on the other end. I know this is a government building. So this is something where just looking at the data points, this is something that most people can have access through public records. But what can you do with this? How do you make this useful and make it powerful? Next slide, please. Thank you. So this is how we're looking at the data. So this is a very New York City specific graph. I'll go on and look at nationally in a second. But from the New York City data sources, which has a great collection of free and open data, I can say that this property ID, so 12345, connects through the address inventory to 123 Main Street. I can also look at another source, and I can look at the transactions, and I can say that 12345, the lender on that was First Corp. Now, in a traditional database or data layout, you would say, okay, property address, lender, You'd have this long list of all the ways that you could add in the data. But if you think of this in terms of a knowledge graph and the way the data is connected, you would say, okay, this property is connected to an address via this source. This property is connected to this lender via this source. If I wanted to add information, let's say I wanted to add in Besides the lender, I know the owner of the property, or I know someone who filed a permit on behalf of this. I'm not going into a database and I'm not extending it and adding in more and more data. I'm just saying there's an extra connection to this property. So I can add in more connections, I can add in more data, and I can extend what I know about the data that way. But to be able to do that, I have to leverage all the work that we're doing to clean addresses and to clean names, because otherwise nothing ever connects up. Now, the reason why we say this is from a New York City perspective, it's relatively straightforward because New York City is very good about cleaning and standardizing data. We go to the next slide. Ron, next slide, please. Thank you. Okay, so on the nationwide scale, we don't have a national consensus as to all of the different all the lots we have. So within our system, we've got 100 million and more lots that we track in our database. We have some ways to track them from a national identifier, but if we're pulling in a lot of these data sets that we want to enhance our knowledge graph with, we might have to match on an address. That's a very common way to do it. Maybe we'll see that the owner has a mailing address that we care about. So we need to match and connect data sources based on that. So let's say that we're looking at tax assessor data. This property has the owner is listed as an anonymous LLC, but the address is 123 Main Street. We know that 123 Main Street is actually connected to Main Street Property Developers, which is a real company, and through another data source we can connect on via the phone. Now to do this, we're pulling in multiple data sets. So we need the names clean, we need the addresses clean to make those connections in the first place, and then it helps us pull in and enhance the data. So for us, this is a goal to add in more attributes, but also to leverage what we've built in the knowledge graph to build great products. So the address standardization, the name standardization is a way to allow us to know more about our data and put it all in one place, centralized around the idea that connectivity is the most important. It's not about creating giant tables of data, it's that something connects to something, and that's how people think about the data, and that's how we leverage it when we build off of it. So what are some of the lessons learned when we built our knowledge graph? So next slide, please. So things that are important, business knowledge is very, very important. So just collecting the data in the first place is great. We've got a lot of smart people doing data science and machine learning at Cherre, but having people who also have experience in real estate and specifically commercial real estate is important to leverage. Having contextual information so we know, when is this data source good? When is this, when are these results that we're using junk or not? That's important. So having smart people is great, but having smart people who also know real estate is the critical component. Next piece. Okay, so the other component that's also hard is it's an engineering challenge. So not just having smart people look at data, but being able to put into a system that we can leverage and build upon. So we have hundreds of millions of properties in our system that we track at the lot level. And so as we collect all of this data, we have something that can, we need to be able to track on a nationwide scale all of the properties at one time. We have to be able to standardize all of these addresses and names at scale because we do have millions of them. As Ron pointed out, there are multiple ways to write a single address. And then once you throw in the unit numbers, it can get even crazier. So you need something that can scale and handle all of the complexity of the data as we're making these connections. Finally, last piece. Yep. So a lot of this is also constantly updating and improving. With big data as a whole, it is hard to determine the quality of your data. You can't just dump everything into a spreadsheet and say, okay, I can eyeball it and it looks good enough. You really have to say, if I've got, we built our knowledge graph, it's got 1.5 billion edges so far, and it's going to keep getting bigger. So if we've got such a large knowledge graph, there's no way that we can always check every single data point to say, how is this useful? How is this relevant to us? We need to say, statistically, how are we doing? What's the long tail that we can ignore? Or what are smart ways that we can cut and slice the data to focus on the aspects of the data we care about? We care about commercial real estate. So, what are things that are relevant in that data set? So it's being smart about how you look and analyze the data as a whole. And then also going back and setting up quality metrics that say, okay, we know that we're great on multifamily in this area, but we're really poor on retail in this area. What can we do to get new data sets to leverage that? So our statistics and the knowledge we gain helps us loop back and then inform product and sales as to other data partnerships we need to add in additional data sets. So it's something that's a constant project. You can't just say, build a knowledge graph and you're done. It's build a knowledge graph with a product focus. So in our case, we specifically care about building owner unmasking. There are other projects that we want to use for leveraging the knowledge graph. So we want to say, okay, if we want to build the best owner unmasking product out there, statistically, where's our coverage? What are we doing? What other data sets do we need to analyze? Because, we need to find ownership information. So for all the properties we have, who owns them? And if we don't really know, if it's some anonymous LLC, can we find data sets that allow us to find the parent behind the LLC? We need really good corporate information. So of all the different corporations floating around, who are they and what do they do? And then contact information is the big key. And that's the thing that, really requires a lot of thought and effort, because there's a lot of companies out there and not everybody's on LinkedIn or has a web page. So we need to find really good sources of data that can, if we unmask an owner, say this property is owned by Main Street Property Development Corporation, and these are the 3 people that you should be contacting and reaching out to if you're interested in learning more. So we're always on this, it's a journey. So developing a knowledge graph and using it to build good products is a journey. And we have to constantly think about how to work with that to expand what we're building. So
I think now we're going to move into the Q&A. I think real quick, just because you mentioned the scale of the number of edges in our knowledge graph, and also all the different types of data, like how would you describe how big our knowledge graph is? And really, what's like the main types of data that you didn't mention that we put into the knowledge graph?
Our knowledge graph itself is roughly 1.5 billion at the moment in terms of edges. I mean, it's big data. It's not massive, but it is huge. So to process it, there's the engineering challenges of figuring out how to extract insights from that data at the scale we're working with. But in terms of the general data, I mean, a lot of it, the fundamentals that you build upon are the public data sources. So assessor data, transactional data, and then we constantly find new data sources. So a lot of it around corporate data as well as corporate contact data to enhance what we already have. I mean, public sources are great. They will get you a good portion of the way, but they're not going to get you, from our analysis, if you just look at public data sources, you'll get decent coverage on owner masking. But you really need to get, if you really want to get as close to 100% as possible, you have to find all these third-party providers that enhance what you already have.
I probably want to add that our knowledge graph is dynamic, but it's not changing really rapidly. Since transactions in real estate and overall the real estate domain is pretty slow, once we have built the comprehensive knowledge graph that represents the entire real estate ecosystem in the United States, the changes to that ecosystem are pretty minimal, I would say. So like say currently we have 500 million nodes in our knowledge graph, and we are just not anticipating this graph to grow to like say 1 billion really soon.
Okay, I think this is all really helpful and really interesting for people who are trying to understand data and a knowledge graph, but I think what really will help make it really like finalize how this matters is to go through like what is the benefit that maybe a broker or investor or developer would get from connecting data and bringing all this data together.
Yeah, I can take it. So in the real estate domain, there is a certain gap between information that is available. So if someone needs to make an investment decision, they probably have lots of information about a specific portfolio that they want to acquire. Like a broker would provide this information. And on the other hand, you have a lot of macroeconomic information about what's going on with the city, where is it heading, is it getting better, is it getting worse, is it getting riskier or not. The gap is in between. So it's very hard for an investor, and by the way, also for the broker and the developer, to know what's going on around your portfolio. Like since, there are buildings around your building, and all those are being owned by someone else. and information about those buildings are not publicly available. And you just have no idea. And it's very hard for you to make a decision if you don't know what's going on in the neighborhood. And many investors and brokers just solve it by legwork, right? Like just they walk the neighborhood, they learn the neighborhood. This is very hard for an institutional investor who wants to invest in a, like, a new place. How can they solve that problem? And this is exactly what Cherre is about. We are connecting data at all the levels, starting from the macro level of a particular market and going down to a floor and unit and literally a room within a unit. So things like that are like all this spectrum is very important, and that's what we're doing at Cherre.
John, did you have anything to add? You look like you wanted to add something. Okay.
I mean, I guess to Ron's point, so one of the efforts that we're, this is kind of large scale at Cherre, is so address resolution, name resolution are important. I would say part of our efforts are also to get really clear and consistent building unit and lot resolution, because a lot of the information that's out there, like you can find out who developed a building, but then learning the individual unit information is harder. And so being able to distinguish between those two is very important. And that's one of the efforts that, besides developing the knowledge graph and the work that Ron and I are doing, engineering as a whole and Cherre as a company is focusing on is trying to determine all the layers of the data so that we can handle them and manage them clearly and concisely.
Great. We actually had a question that came in that I think is tail end of this. Does the knowledge graph have a universal application, or do we have to make adjustments to the model for different regions or countries?
So at the moment, it is US based. We do, we're interested at some point to talk about, future expansion outside of the US, but at the moment, we're just looking at US sources to get ourselves developed. Yeah, I'm definitely pleased to talk to Caroline, and lots of exciting things to talk about at the booth about all the different opportunities we have with our data partnerships, as well as the data we offer out of the box. But the knowledge graph itself, primarily, our big development is on developing owner masking, but also we kind of look at it as a foundational layer for other products we'd like to develop. Any place where you're leveraging the connectivity of the data itself, so you're not just looking at the property features. Traditionally, when it comes to modeling and the like, you would say a building has so many floors, so many square footage, so many bathrooms, the normal features of, does it have a sprinkler system? If you want to develop on top of that, especially in commercial real estate where there isn't as many data points to work with, that you need to say who owns this property. So besides owning it, like you can then flip it and say, what's their portfolio? So now that I know that Tishman Speyer owns this property, what are all the other properties that Tishman owns? And then you can leverage that to build other products. I mean, Ron, would you like to make any comments about our future plans for leveraging the knowledge graph?
We'll give Ron a second to think.
So what I wanted to say is that I agree with you, John, that our knowledge graph is the foundation of many different types of analytics that we can build. And we do consider building new types of analytical solutions at Cherre that we can't really talk about right now. But overall, it is not just, we don't build the knowledge graph for a specific application. We build it for the future applications that will come. And what is very important to understand is that it's the platform, the knowledge graph as a platform is very generic. It allows many applications to build upon it. And it also allows to incorporate international data in a very unified form, pretty much as we do that for US data, for US knowledge graph.
All right. Sarah asks, can you customize model or data science on top of this to develop proprietary investment theses?
Yes, for sure. This is why we're building it for. So if a specific customer has a specific need, we provide a platform that a model can be, developed on that specific platform. So we propose two different offerings. One is we'll just provide you access to the platform and you will build the application all by yourself, or we can do it together. And that's why we have a strong data science team at Cherre.
Great. I think we're over time. We're just coming up on our time for our session. So I'd like to ask if you guys have any last closing thoughts before we wrap up that you would want to share with the audience here. Not to put you on the spot.
What I wanted to say is that the new times, the new reality of COVID or hopefully post-COVID is definitely changing the real estate industry, and the industry is becoming much more data-driven. I really hope to see that change really soon, because investors have to realize that without the data, it's very hard for them to invest now, because the reality is changing and the knowledge that they gathered over the last 50 years might not be relevant like in a year from now. So we really need to be data-driven to make smart and profitable real estate investment decisions.
All right, with that, let's wrap up, and thank you all for joining us today here at CREtech, the Reimagining Real Estate Summit. You can see Ron and John's emails there. If you guys have any follow-up questions, you can also come visit Cherre in the expo and stop by our booth and chat with us and ask your questions. And we are so glad that you were able to join us. Thank you, everyone.
Thank you very much.